So this is one of my favorite weeks of calculus because everything builds on each other really nicely and things start to come together as far as what our graphs look like. Basically, the focus for the next couple weeks will be what calculus tells us about a graph. And by the end of the next couple weeks, we're going to be able to take a graph, do some calculus, and use the calculus to get a picture of what it looks like in a pretty exact manner without having to rely on our calculators to graph it. Okay? So there's going to be three different things that could happen in our function. Okay? Our function could increase, our function could decrease, our function could be constant. Okay? If we look at intervals, if we look at it, just from one point to the next, we could be increasing, decreasing, or staying the same. Okay? So let's talk about what it means calculus-wise, and this is kind of a review, but let's just talk about it. This is what it looks like for f to be increasing. F is increasing because our y values are getting bigger as we go from left to right with our x's. Okay. What do we know about the derivative here? Okay. If f is increasing, we know that our derivative is positive. Okay. Okay. Nothing new? Nothing new. Okay. Our function could be decreasing. Okay. And if our function is decreasing, what do we know about the slopes? What do we know about the slopes, Colby? Okay. If f is decreasing, we know our slopes, our derivative, is less than 0. And then it doesn't happen very often, but we could have a moment in our graph where we have no change in y, which means we're constant. And what's true about the derivative here? 0. Okay, if f is constant, we know our derivative equals 0. Okay, so what I'm going to do is on the next slide, I'm going to put up a picture. And I know it seems very basic, but I just need you to get that mental picture of what's happening when we find things about increasing and decreasing and constant, okay? Because we're going to get into like more of the calculus algebra side of things instead of looking at graphs. So take about a minute or so, and with your pod, please tell me where f is increasing, decreasing, and constant, okay? Talk about it with your pod. I'm going to come and collect your cards.
I can't see the bottom.
We're already ready. That's cool.
Okay, so or
It's like a basic.
All right. Rebecca, where is f increasing? All right, from -3 to 1. F is increasing. Okay. Maddie, where is f decreasing?
From 3 to 5.
Okay. And f is constant. Where, Andre?
from 3, like constant from 1 to 3.
Okay. So we have a mental picture of what's going on. Okay. What I'm going to ask you to do is I'm going to ask you to take an equation, and you're going to find me where our graph is increasing and decreasing. Now, you're not getting a graph. You're not graphing it to find it. You are going to use calculus. Okay? Now, flashback to Friday. Flashback to Friday. When we have those turns, right, those could potentially, well, when we have turns, we change from increasing to decreasing, right? And what did we decide about the derivatives at those turns? They equal 0, okay? Or, like an absolute value graph, changes us from decreasing to increasing here. What's the derivative there? Undefined, right? There is not a derivative there. Okay? So we need to figure out what our critical points are, because that's where we could potentially have a change in direction, right? If we have a turn, okay, we would be switching from increasing to decreasing. You know, like those corner points, we could be switching. Maybe not, but we could. Okay? So you're going to find critical points just like you did on Friday. Okay? But then what I'm going to ask you to do is I'm going to ask you to put those critical points on a number line. Why would I ask you to put them on a number line?
Pass.
Okay, I'll get it.
Okay.
Okay. If we can determine what's happening in between the critical points are our only options of changing directions. So in between critical points, if our derivative is positive, it's positive for that entire chunk. Okay? If in between two critical points our derivative is negative, our derivative is going to be negative for that entire chunk. So we're going to test intervals. Okay? You're going to put values into your derivative to figure out, are my slopes negative here? Are my slopes positive here?
Are we testing the critical points in the derivative instead of?
We're testing like in between the critical points in the derivative to determine if they're positive or negative so that we can write which intervals are increasing, which intervals are decreasing. Okay.
Is it just one value in between?
Mm-hmm. Like, let me give you, like if this were our graph, Colby, we would have two critical points right there. Those are the two places this polynomial has a derivative of 0. So if we test one x value in between here, we'll get a negative derivative, and we know that it can't change in between there because there's no change of direction if there's no other critical point. Okay? So what we would find on this graph, like if our equation was this, we would find that we had two critical points, and our graph had positive slopes, and then negative slopes, and then positive slopes. So that we could talk about increasing and then decreasing and then increasing. Okay. Okay. So should we do a nice simple one first? We like simple first. Okay. I also know a lot of you like steps. That's why I gave you steps so you can keep turning back to them. Okay, so let's do a nice simple one. I want to know where this function is increasing and decreasing. Okay, first step. Okay, find the derivative. That's kind of like step 0, right? If we're going to find critical values, we got to find the derivative. So our derivative is 3x squared minus 12. Are you okay?
My leg broke.
Oh, okay. I thought you injured yourself doing calculus. That would be impressive, but okay. Do you agree with my derivative? Okay. Now we need to solve. Okay? And you can do this a couple different ways. You can factor out a 3 and you can factor. Or you could move the 12 over and say x squared is 4, so x is plus or minus 2. You have some options, and that's nice, right? I like having options. Okay? All right, so these are our critical values. Step 2 was to put your critical values on a number line. Okay? And I know that you don't know any different, but go ahead and label that this number line represents our derivative. That's what we're going to be plugging our values into. And come Wednesday, we're going to start talking about what the second derivative tells us. So we're also going to do this with the second derivative. Okay? So I want you to put those values on the number line. Okay? At this point, we're just going to test our intervals. Where is our derivative positive? Where is our derivative negative? That's all we're doing. And I've labeled our number line with derivative so we know that's where we're going. Okay? So yell out a number less than -2.
0. Oh.
-3. Doesn't matter. No. But let's come back to the derivative. If we plug in -3, 3 times -3 squared minus 12, what kind of a number is that?
Positive.
It would be a positive number. So our derivative values for that whole interval will be positive. Okay, Colby, pick a number between -2 and 2. When we plug 0 into our derivative, what kind of number do we get? We have a negative derivative. And then pick a number bigger than 2. 3. If we plug 3 into 3x squared minus 12, we would get a positive number. Okay, what does this mean? This means from -infinity to -2 and from 2 to infinity, our derivative is positive. And if our derivative is positive, what does that tell us about our function? Okay. We know that from -2 to +2, our derivative is negative. And if our derivative is negative, we know that our function is decreasing. That is all you have to do today.
Yeah.
Okay, why did I say this was the easy one?
Because it's the hard one.
What kind of function is it?
Polynomial.
It's polynomial. Polynomials are the simple ones to work with, right? So let's talk about what's happening. Okay, this is happening where here's -2, here's +2. We go from increasing to decreasing to increasing. That's what our function looks like. Okay? Now, this wasn't bad. Okay? What's going to make it more complicated is just the kinds of derivatives that we have to take and simplify. This, testing intervals, not the hard part. Finding derivatives, not the hard part. Simplifying your derivative to set it equal to 0 and undefined, that's where things could get messy. But I said could. I feel like this may have been similar to a problem you did Friday. No? Yes? Okay. Well, whether it's from Friday or not, it's been a few days and we've obviously forgotten. So if it is the same. Okay, I want to know where this guy is increasing and decreasing. So let's find the derivative. Take 1 minute, write down what the derivative is. Don't simplify it. Just do it like you would on the test last week. And then compare it to your neighbors if you didn't do it already.
Love it.
Oh my god. Maybe I could benefit from having
Okay.
bring my grade up. What'd you get?
Yovana, what do you have?
Thirds x squared minus 9 to the negative 1/3, and then 2x.
Okay, how do you feel about that? Okay, now we need to rearrange this so we can find our critical values. So anytime you have a negative exponent, please take it to the denominator or other side of the fraction bar. Okay, so then we're going to have 4x and 3. Does that seem reasonable to you? Okay, so if we're going to find critical points, we need to know where this is 0 and undefined. Okay, when we have a fraction, essentially we set numerator equal to 0, denominator equal to 0. Okay, so if I want our derivative to equal 0, then we set our numerator equal to 0. So 0 is a critical point. Okay, if we want our derivative to be undefined, we need to set our denominator equal to 0. Where does that happen? Thank you for saying plus or minus 3.
How did you do that?
You can just look at the inside and that'll be 0, so you don't have to look at the other side. So just x squared minus 9.
So we have a product that equals 0. And so I took this factor and set it equal to 0. Are you with me? Yes?
Yeah.
Do you want me to do some algebra?
Like, why don't you do anything with the...
Okay, so divide by 3. X squared minus 9 to the 1/3 equals 0. Cube both sides. X squared minus 9 equals 0.
Oh, okay. Yeah.
Okay.
I was just confused about the power. Keep going. Hold up.
Hold up what?
No, I was 0 times 0, not 0. He said she did.
Oh, yeah.
How did you know I wanted to do 0?
Huh?
I said, how'd you know I wanted to do 0? Never mind.
0 is a critical point. I have to put them on. So we can't choose 0 this time. Okay? Okay, so please don't get too hung up on what the actual value is going to be. All you care about, is it going to be positive, is it going to be negative? So if we choose like -4 in this interval, -4 is going to make the numerator negative. Is it going to make your denominator negative? Because you would have 16 minus 9, which is positive, and then you do a bunch of stuff with it, which we don't really care about, but we have negative over positive. Okay. All right. In between -3 and 0, -1. So this would be a -4 in the numerator. You would get 1 minus 9 here, do a bunch of stuff with that, which we don't care the value of. But we would have negative over negative, wouldn't we? Are you not convinced?
No, I believe you.
Okay. If we choose a number in this interval, like +1, we would have 4 over 3 times 1 minus 9 to the 1/3. That's going to be a negative number. And if we choose a number in this interval, like +4, we would have 16 over 3 times the quantity 16 minus 9 to the 1/3. Those would all give us positive values. Now, is it always going to alternate? No, don't get fooled. Okay, you have to test every one. But from the number line that we have, we know that our function is increasing from -3 to 0 and 3 to infinity because that's where our derivative is positive. We know that our function is decreasing from -infinity to -3 and 0 to 3 because that's where our derivative is negative. Now, when I gave you the function of x squared minus 9 to the 3, what's the function? X squared minus 9 to the 2/3, did you know what that looked like? You have no idea what that looks like. Now we have a little bit of information about what that looks like. We know it's going to decrease, then increase, then decrease, then increase. Plug it in your graphing calculator. Somebody at your table has a graphing calculator out. Have them plug it in and share it. It's going to take me too long to get mine pulled up because it's very slow. Okay, share it with your pod. Kind of looks like this, right? Okay, you just said something about a corner, right?
Yeah.
-3 and +3 is where our derivative was undefined. 0 is where our derivative was 0. Does that match this graph? Yeah. But notice how just because the derivative is undefined doesn't mean it's not continuous. Okay, talk at your pod. Just because we have a critical point doesn't mean we have a change in direction. Why or why not? Either way.
Yeah.
Go like this, and then we approach here. It's not like this one happening. It's just like saying.
Yeah, so it's like,
Is that the next thing?
Yeah. Okay, how many of you vote yes? Critical number means change in direction. Ooh, who can give me an example of something that would contradict that? You all are saying no, so give me a counter example. Oh, a cubic function. What's the derivative of x cubed?
2x, 3x squared.
What's our critical number?
0.
0. CP, critical point. All right. If I plug in 1 to our derivative, what kind of value do we have? If I plug in -1 to our derivative, what kind of value do we have? Positive. Okay, the cubic function, kind of like what we talked about in number 8, Grace's question, right? It increases, flattens out, increases. So we get that critical point because our derivative is 0, but it doesn't change direction. Okay? If I asked you for the increasing intervals of this function, you would have to tell me -infinity to 0 and 0 to infinity. You could not say -infinity to infinity because at 0, the derivative is 0, not positive. Excuse me?
Sorry.
Are we done? Are we done?
We still got about a year left.
I want want you to find me this derivative. We may not get to finish this problem, but I think talking about its derivative and simplifying it might be a good idea.
Should I use it?
Okay, so I know some of you are very tempted to make this a product rule. Let me just give you this warning. You are going to have to determine where your derivative is undefined. And if you have one fraction, that's very easy to do. Okay, so if you did the product rule, you would have to do like we did up here and find common denominators to combine to get one fraction. Okay, warning. So our derivative, let's just kind of remember what we do here. So 4x cubed times x squared minus x to the fourth plus 1 times 2x all over x squared squared. Okay, now that's all fine and dandy. You could do that for last week's test, but now if we're going to figure out where this is 0 and undefined, you got to simplify it all the way down. Okay, so this would give us, okay, minus 2x to the fifth minus 2x all over x to the fourth. So we have 2x to the fifth minus 2x over x to the fourth. Okay. I would go one step further, and since you could factor out an x, and we have an x to the fourth down here, I would do this. I would factor out a 2x from here, because then we could cancel out this x with one of these. Ooh, I'm writing with my left hand. And now I think it's really nice to work with, and I could almost just look at that and figure out what my critical points are, right? Our numerator is 0. Oh, we can finish this problem, no doubt. Yeah. Easy question. Where's our denominator 0?
0.
So 0 is a critical point. Where's our numerator 0? Plus or minus 1. Okay. Now the only thing that kind of stinks about this one is that we're going to have to plug in fractions, right? But that's not terrible, right? Let's start there since that's going to be the most intense. Let's start with this interval right here. If we pick 1/2, do we actually have to find the derivative value? No. We know that 1/2 to the fourth minus 1 would be what kind of number? Negative. Over 1/2 cubed. Negative over positive would be negative. Okay? Since we're thinking about it, let's think of negative 1/2. Negative 1/2 to the fourth minus 1 would be what kind of number? Negative, because that would, negative 1/2 to the fourth would turn to a positive teeny tiny fraction. Minus 1 is negative. But negative 1/2 cubed would also be negative. So we would have a positive interval there. And I'll save you time. I've already done these. Is that number line your answer? No. No. You give me the intervals by interpreting what that means. Tomorrow we're going to use this to pick out even more information. Okay? That's just kind of our guide. Alright? Thumbs up, thumbs middle, thumbs down. How do you feel? Currently, I mean, if you're nervous, that's fine. Okay. If you're nervous about the algebra you have done with your derivative, feel free to check your work on Calc Chat to know whether that was correct or not. Okay. Jesse's not here. McKenna, Sean, Yovana, you aren't here to get your test back. I want to talk to you.